Hello, I'm Dr. Anismani, and this is the third session in the biostatistics and research tools in medical science, coming under the subject of preventive and social medicine. You can also see similar concept bridge in the channel youtube.com/acpgmet, and please also have an account in the facebook.com/acpgmet. So please visit the channel youtube.com/acpgmet regularly. More than 80 videos have been uploaded so far, and more than 8,000 hits have been made in the channel, and it is becoming popular among all medical students all over the world. More than 125 countries have been receiving this channel wholeheartedly. Thank you for your cooperation. The 2x2 table and its concepts. The 2x2 table, a table that consists of two columns, that is vertical column that represent the presence or absence of a disease, and two rows, that is horizontal, that represent a positive or negative test result, is called a 2x2 table. These tables may also be employed in risk factor studies, where the rows represent the presence or absence of a risk factor, and in hypothesis testing, where the rows represent the acceptance or rejection of the null hypothesis. Following 2x2 table is a tool for the evaluation of standardized screening tests which predict the presence or absence of disease. You can see the disease marked in the top, present or absent. On your left side, test marked positive and negative. Under the present disease and the test is positive, it is marked A. Disease is absent but the test is positive is B. Disease is present but the test is negative, that is C. The disease is absent and the test is negative, that is D. So there are two things you can add together. Horizontally A plus B and C plus D. Vertically you can add A plus C and B plus D. A plus B indicates the test is positive. C plus D indicates the test is negative. The A plus C indicates the disease is present. B plus D indicates the number of cases where the disease is absent. And the letter A indicates true positive. The letter D indicates true negative. The letter B indicates false positive, and the letter C indicates false negative. This table and the letters, the additions, are very basic in statistics and should be understood by the candidate very well. Otherwise, it will be very difficult to follow the basics of statistics, because everything in medical statistics is based on this 2x2 table. Reliability and precision. Reliability is the dependability of a test result. How much you can depend on the test result. Reliability is the dependability of a test result. Precision is the extent to which random variability is absent from a test result. Precision is the extent to which random variability is absent from a test result. There is no variability in the test result. The reliability of a test is directly dependent upon its precision, because random variation in a test result precludes the test ability to be consistent and reproducible, and therefore reduces its dependability. The precision, consistency and reproducibility. The precision of a test are the characteristics that determine the degree to which it may be considered reliable, that is durable and dependable. The precision of a test are the characteristics that determine the degree to which it may be considered reliable. Precision, consistency and reproducibility. Reliability is durable and dependable. Diminished precision in a test is the result of what is commonly referred to as random error. Diminished precision in a test is the result of what is commonly referred to as random error. Validity and accuracy. Validity is the extent to which a test measures what it was designed to measure. Validity is the extent to which a test measures what it was designed to measure. Accuracy is the ability of a test to produce a true value for the measurements and true classifications for the samples under study. Accuracy is the ability of a test to produce a true value for the measurements and true classifications for the samples under study. Screening tests should be able to identify the presence or absence of a specific disease. There is validity. Screening tests can do so only with true measurement of the markers of that particular disease and true classifications of same population, that is accuracy. Diminished accuracy in a test or study is most often the result of a non-random type of experimental error called bias or systemic type of error called bias. Diminished accuracy in a test or study is most often the result of a non-random type of experimental error called bias. So the error in accuracy is bias. Validity has two components, sensitivity and specificity. Sensitivity is defined as the ability to correctly identify individuals who have a specific disease or condition. Sensitivity is ability to identify correctly people who have a specific disease or condition. Specificity is defined as the ability to correctly identify individuals who do not have a disease or a condition. Specificity identifies people who are not having the condition or disease. Sensitivity, those who have the disease. Specificity, who do not have the disease. Although the validity of a diagnostic test can be determined by sensitivity and specificity, three other measures are also important: false positive rate, false negative rate, and accuracy of a test. False positive rate is defined as the proportion of false positive among non-diseased subject. I already told about B plus D and the definition of B. So false positive rate is defined as the proportion of false positive among non-diseased subject. Then false negative rate is defined as the proportion of false negative among diseased subject. So denominator is how many people have the disease, and the numerator is the number of people who have the false negative result in the false negative rate. Whereas in the false positive rate, false positive case is the numerator and the non-diseased cases are the denominator. The fifth term you have to understand is the accuracy of a test. This is defined as the proportion of true result, that is true positive plus true negative, A plus D, among all test result, that is A plus B plus C plus D. The accuracy of a test is defined as the proportion of true result among all test result. So once again, false positive rate is defined as proportion of false positive among non-disease subject. False negative is proportion of false negative among diseased subject. Accuracy is true result among all test result. So let us master the first 5 components of screening test: sensitivity, specificity, false positive, false negative, and accuracy of test. See the diagram. The disease is present, disease is absent. The test is positive, test is negative. The test is present, the test is positive, it is A. Test is disease is present, test is positive is A. Disease is absent, test is positive is B. The disease is present but the test is negative is C. Disease is absent, test is negative, that is D. In the vertical column, the disease is present. So number of cases where the disease is present is A plus C. The second column, the disease is present, absent. Disease is not present, that is absent, that is B plus D. The horizontal row, test is positive, A plus B. The test is negative, C plus D. So here the sensitivity is, what do you do? The numerator is the test is positive and disease is present, that is A, divided by the number of people who have the disease, that is A plus C. That means sensitivity detects the people who have the disease. Specificity is, which means patients who do not have the disease. So naturally the denominator is B plus D and the numerator is the test is negative and disease is absent. So it is D by B plus D. False positive rate B divided by B plus D. False negative rate is C divided by A plus C. False positive means the test is positive but the disease is absent. So no disease is B plus D, test is positive is B. False negative means what? The test is negative but the disease is present in such people. So to take the total number of people who have the disease, that is A plus C is the denominator and the numerator is test is negative. Now what is this accuracy? We already told that the true result is compared with the total result. So A plus D, A is the test is positive and the disease is present. D means the test is negative and the disease is absent. So that is the sum, that is the numerator. And the total number of people in whom we did the test is A plus B plus C plus D. So that is the denominator. I think this part is well understood. Please read it once again and have a picture of this on your on the wall in front of your table, study table, so that you can see this at least once in a week and make it say memorized in your brain. It's very important. Now the receiver operating characteristic curve, ROC curve. Receiver operating characteristic curve, ROC curve, as graphic illustration of the differences between the sensitivity and specificity of two diagnostic tests that are reviewed for the purpose of comparing their validity and effectiveness. By plotting the true positive rate, that is sensitivity on the y-axis, true positive on y-axis or sensitivity on the y-axis, and their corresponding false negative rate, that is 1 minus specificity on the x-axis, we are able to select the more accurate of the two tests by selecting the curve that lies closer to the upper left hand corner of the graph, that is where the true positive sensitivity is equal to 1 and the false positive, that is specificity, equal to 0. For example, comparing the sensitivity and specificity of two diagnostic tests for syphilis, a researcher plotted the following ROC curve for the VDRL, that is Venereal Disease Research Laboratory, and FTABS fluorescent treponemal antibody absorption test. As you can see, the FTABS test curve lies closer to the upper left hand corner of the graph, where the true positive rate sensitivity is equal to 1 and false positive rate, that is 1 minus specificity, is equal to 0. It was therefore found to be both more sensitive and more specific than the VDRL test for the detection of syphilis. Point A and B of the FTABS and FDDRL test respectively represent the best cutoff point for each test. The cutoff point will be discussed in coming video sessions and can be determined by the locating the point where the tangent to the line of the curve is equal to 45 degree. Accuracy of the test is determined by measuring the area between the curve and a 45 degree line drawn from the origin of the graph. So you can see the ROC curve, the true positive rate sensitivity on the left side vertical axis from 0 to 1, 0.1, 0.2, 3, 4, 0.5, 0.6 in fraction, and on your right side in the horizontal axis you can see false positive rate, there is 1 minus specificity marked from 0 to 1, that is 0.1, 0.2, 0.3, 0.4, and the angle 45 degree is also marked. The VDRL test is marked and the point B is marked. The FTABS test is also marked and the point A is also marked. And this is the ROC curve which is the researcher used for testing the two laboratory test, FTABS test and VDRL test, and about which I explained just a few seconds ago. Effects of the cutoff point on sensitivity and specificity, about which I just told. Cutoff point of a screening test has an effect on the sensitivity and specificity of the test and can be demonstrated by the following example. Let us define an appropriate cutoff point for a diagnostic screening test like fasting blood sugar to detect the presence or absence of diabetes mellitus. If we set the cutoff point of the diagnostic test too high, like point B in the following figure, the test will miss the detection of mild hyperglycemia. Conversely, setting the cutoff point of the screening test too low, like point A in the following figure, will cause the test to detect some of the normal subject, like absence of diabetes, as being hyperglycemic. So a summary of these effects is given in the following figure. You can see on the left side there is no disease, that is true negative. On your right side the disease is true positive. And there are two lines which are drawn. A and B are the 2 points marked. On your left side you can see the minus sign and on the right side you can see the plus sign. And there is a cutoff point in a screening test shown here, and cutoff point A on your left side that shows the greater sensitivity, greater false positive rate and lower specificity, and the cutoff point B is lower sensitivity, greater false negative rate and greater specificity. Hope that you understood this figure well. So I am keeping this for a few more seconds for you to understand the figure. You can always play the video once again to understand these statistical concepts. The predictive value of a screening test. The predictive value of a screening test measures the true presence or absence of a disease. Predictive value has two components. A positive predictive value is the proportion of true positive among all positives. A negative predictive value is the proportion of true negatives among all negative. With this background knowledge, let us master two more components of the screening test: positive predictive value and negative predictive value. Positive and negative predictive value, again the same chart, 2 by 2 column. That is, the disease is present, absent, test is positive, negative. A means the test is positive, disease is present. B, test is positive but disease is absent. C, test is negative but disease is present. D, test is negative and disease is absent. And the sum of patients who have the disease is A plus C. The sum of patients who did not have the disease is B plus D. The sum of people who had test is positive is A plus B. And the sum of people who did not have the test positive, that is negative, is C plus D. And what is the positive predictive value? The test is positive in A out of A plus B. So positive predictive value is A by A plus B. and how many people had negative value C plus D, and of which true negative was D. So D by C plus D is the negative predictive value. This is easy to understand. Don't confuse with the previous equations which I told about the specificity, sensitivity. The relationship between prevalence and predictive value of a test. In general, the usefulness of a diagnostic screening test is affected by the prevalence of a disease. If the prevalence of a disease is low, positive predictive value is likely to be low. If the prevalence of a disease is high, positive predictive value is likely to be high. For example, the enzyme linked immunosorbent assay ELISA is being employed in the screening of routine blood donors for the detection of HIV positive antibody. By using the ELISA, the prevalence of HIV antibody among those screened was found to be less than 1%. This low prevalence will yield a low positive predictive value for a screening test. Conversely, the VDRL is being employed in the routine screening communities for the detection of STDs, sexually transmitted disease. Using the VDRL test, the prevalence of STD among those screened was found to be high. This high prevalence will yield a high positive predictive value for the screening test. The explanation I just given: low prevalence, low positive predictive value; high prevalence, high predictive value. So the concept is 2 by 2 terminology. The disease is present, test is positive is A. Disease is absent, test is positive is B. Disease is present but the test is negative is C. Disease is absent, test is negative, it is D. The sum of people who had the disease is A plus C. The sum of the patients who do not have the disease is B plus D. Sum of people who had the test positive is A plus B. Sum of the people who had the test negative is C plus D. The equations are once again recalled here. Sensitivity is A by A plus C, that is true positive by true positive plus false negative. Specificity is D by B plus D. It is true negative divided by false positive and true negative together. False positive rate is B by B plus D, that is false positive by false positive plus true negative. False negative rate is C by A plus C, that is false negative by true positive plus false negative. Positive predictive value is A by A plus B, that is true positive by true positive plus false positive. False negative predictive value is D by D plus C, that is true negative by true negative plus false negative. Accuracy is A plus D divided by A, B, C, D added together, that is true positive plus true negative divided by all positives and all negatives. These equations are important to be memorized, so please have a printout of this and keep it in front of the table or the wall where you are likely to see every day, or the door behind the door. Whenever you close the door, you can see this. For example, an investigator evaluated 100 patients suffering from major depression as confirmed by the attending psychiatrist. The results were as follows. Clinically, depression present in 12 people, absent in 28 people. Absent in 18 people. Clinically, the depression was present in 12 people and absent in 18 people. Clinically, the depression was detected by a test. The test was positive in 12 people and it was negative in 18 people. Test was negative in 28 people and 42 people showed test negative. The disease was present but the test is negative in 28. The disease is absent but the test is negative in 42. So altogether added in the vertical column, the depression is present is 12 plus 28, that is given on your left side. The disease is absent, depression is absent, the sum is 18 plus 42. The test for the depression used was positive in 12 plus 18. The test used to detect depression was negative in 28 plus 42. The total number is 100. So that is a clinical scenario you got. The 2 by 2 column A, B, C, D. Now find out the answer for the following questions. On your left side, 7 options are given. On your right side, 7 terms are given. Match the ratios and the options. The sensitivity, specificity, positive predictive value, negative predictive value, false positive rate, false negative rate, and accuracy of a test. Please write down the answer. The answers are given at the end of this video session. Take your own time. I will give some more time for you to calculate. Okay, the time is over. 2 minutes were given. The next question is, the extent to which a test measures what it was originally designed to measure is described as which one? Sensitivity, specificity, validity, reliability, and true positive value. Now match the following lettered options with the following numbered items: validity, systemic error, reliability, random error, and precision. The questions are: depends on precision, dependability of a test, dependence on accuracy, consistency of a test, limited precision in a test, and limited accuracy in a test. Six questions are there. 5 options. Okay. For the questions which are following, the table should be consulted, which is well known to you. The disease is present or absent, test is positive and negative. The disease is present, test is positive A. Disease present, test is negative C. Disease absent, test is positive B. Disease absent, test is negative D. And the sums, the rows A plus B and C plus D. Vertical columns, disease is present A plus C, disease absent B plus D. On the basis of this, a few questions are following. A false negative value, it is represented by which one? False positive is represented by which one? True negative is represented by and the true positive is represented by The following two hypothetical distribution curves represent the effects of altering the cutoff point for serum cholesterol level in a test for classification of individuals who are at high risk for developing coronary artery disease. The chart shows the diagnostic screening test and cutoff points, and on the left side you can see the no disease curve, and the right side you can see the disease curve, and the points marked are A and B, and the lines C, D, E, F, G, H are marked there. Match the following numbered items with the designated letters of the figure given in the preceding example. The cutoff point set too low, the cutoff point set too high, the cutoff point of greater sensitivity, the cutoff point of lesser sensitivity, cutoff point of greater specificity, and the cutoff point of lesser specificity. Answers are given at the end of this video session. Please write down your answers now itself, and we shall check the correctness at the end. Cutoff point of the greater false positive rate, cutoff point of greater false negative rate, true positive for cutoff point X, true positive and false positive for cutoff point X, true negative for cutoff point X, true negative and false negative for cutoff point X, false positive for cutoff point A, and false negative for cutoff point B. So the answers are given here. 5A, 6C, 7D dog, 8E, 9B box, 10F, 11G, 12C, 13C, 14C, 15A, 16E, 17D dog, 18B box, 19C, 20B box, 21D, 22A, 23A, 24B box, 26A, 26B box, 27B box, 28A, 29A, 30B box, 31F, 32D, 33E, 34C, 35E, 36F. Hope that the session was useful to you. Next session will be hypothesis testing. Goodbye from ACPGMet. Please visit the channel youtube.com/ACPGMet. More similar sessions on the entrance test oriented sessions and also concept bridge will be available in the YouTube channel. You can also send me email in the address acpgmet@gmail.com or drnsmanimd@gmail.com. Thank you.